Well, we do have plenty of questions to get to, and Charles, you're getting loaded with questions coming up here, so we want to get back to some of this social network analysis, and we have many questions along this topic, and quite simply, someone said, when I try to use social media data with Facebook, it asks me to copy an access key. I don't know what that is. Can you walk us through, starting fresh inside Mathematica, how do I get into my Facebook data?
Sure. So, I just have, my blank notebook here. So let's suppose I want to just, build my friend network in Facebook. I use social media data, Facebook. And then I do, friend networks. So the first thing is that Mathematica goes and try to check if you have the, the latest version of the data packet available, on your machine. And then as soon as he checked, if, like in my case, I have the latest one, which was, pushed at the release, you get the window where it actually asks you to sign into Facebook. And down here, it kind of explains you the process. If you go and sign in on Facebook, we'll find out the access key. I will show you later, and then you have to pass it on the window below. So let's go ahead and click on this button. So I get, the window of authentication from Facebook. So this authentication is on Facebook side. So if you just provide your email or phone number and then your password, in my case. So if you're a new user, the first thing you get is that you have the introduction windows where actually Facebook tell you which type of information will request from you. And this happened just the first time. So you have the information, your basic information as well as the type of information we want to provide you. So if you approve the application, you click on Go to Applications. And then there is some extra information we also may want to provide you. For example, what is your feed? You may decide to skip it or to allow it. You'll not affect the functionality. So if you allow all that, Facebook authorizes the application, and then you get a new window with the Wolfram logo and Facebook where you have the access key. So you highlight it and copy it. And then you go back to Mathematica and paste it in the window. So that's the access key you get. So you generate for every user, and it's confidential, it's an encrypted, access key. And then you click OK, and then, we connect to Facebook with that access key and get the network. In this case, sorry, my network is quite small. We just have 4 people in Facebook. So that's actually kind of the process you have to follow, and it's the same process you will have on Twitter, LinkedIn, and such a thing. So all rely on access key. And you see also the window and the clear explanation of that.
A few other questions from some viewers here. On social media graphs, is there a way to influence the way the graph is presented? For example, circle size not depending on the friend number.
Yes, definitely. It's a Mathematica object. You can manipulate it, change everything you want. So in this case, I will just try to show you how you can change the vertex size.
The notebook a little bit too?
Yes. Let me go to 150. Much better?
That looks good.
Okay. So actually, the way we represent network is through graph. So what you have there is actually a graph. So we provide functionality to add properties. So we call them property. In your case, you call them a node attribute. But in this case, you can use set property of the graph above, and then you can say, since you want to change the vertex size, let's suppose we want to reset them. So I do vertex size goes to. And in this case, I will give a pattern because if each one is predefined already. So I will say I will assign a value to, let's say, 0.5. And then evaluate. And then I get a new graph with all the vertex size reset. And here, you can do the same for all the property, including the vertex style, the layout, and everything.
Oh, and then a few more questions here, and very popular feature. And again, if you have a lot of these questions, head to the documentation center, and there's a lot of great code examples and guides, and it'll walk you through how to do a lot of this. But Charles, how do you add the node attributes to the network?
Right. So as I just pointed out, so you can, if we take the same example, so let's suppose, okay, I will just do a vertex list to actually know the different vertex there. So I know the vertex in this case that the friend IDs in our network. So I just want to make sure they're strings. So I will just let me call this graph G. So it's the same graph you have as the list of vertex IDs. So I will just set, property of my graph. And let's suppose I want to change, the property. I want to set the property for the first vertex there. So let's call this V, for example. And then I will say V1. And then I will set my property. Let's say my property. And then I will say here, for example. So this regenerates the same graph and is a property. So it's not a visual property, but it's kind of kept inside your graph. So if you do property list of the resulting graph, so this is pound 8, vertex list, you get the list of current property. So unfortunately, in this case, I probably have a mistake in my construction. So I will just kind of show you that in a different way. So I will just build a random graph 1020, for example, sorry. And then I just do the same, set property of my first vertex, and then I will say my property goes to here, if I manage to type that. So I get the same graph, and then I can do property list of my graph, which is 11, and then I will say the first vertex. So I get the property list, and you see that the new property is actually added to the graph there.
You would probably got that there if you asked for vertex 1.
Pardon?
In a social graph, you didn't specify vertex 1.
Vertex 1, yes, that was my mistake. Sorry about that. And you can actually then query the property if you do a vertex property value of the resulting graph. So this will be 11, 1, and then you say the property, my property, and then you get the value. So you can just manipulate, add your own personal, all your property, or use the predefined property and styling and modify
So
them.
one example of where this might be useful, you showed an example before, Charles, where for homophily, whether you're going to associate with the same kinds of people or not, where you added another property called race, right?
Yes.
And that was done exactly this way that Charles demonstrated.
Right.
And that can also be used for some of these social network analysis. So assortativity can take additional properties into account. So race happens to be one thing for this graph.
Right.
One more question. This is for anybody up here on the panel. Do we have any statistical test that supports the comparison between two or more networks?
So if I understand it, so essentially, if you have a network and you want to compare it, I believe you'll have to first, to compute a value or generate a value. Let's suppose you compute centrality, so you get a set of data. So I believe from there you can directly use all our statistical tools which are available, including statistical tests. And I'm sure Roger can, say more about all the statistical tests we have for data.
I have a little bit hard time understanding the question. Between two networks?
So I believe, you probably need to convert it to a property of the network. Let's suppose, you have two networks or several networks.
Yeah.
You can compute the centrality or obtain some data related to those networks, a numerical value,
Right.
and then from there.
So one thing that Charles showed, and one thing that you often do, is that you compute some value, a real number, like centrality or page, that is an actual real number. So one question that you can ask is this one statistically bigger than this other one? And that would be a mean test, basically. Are they expected, are they the same, or are they significantly different?